We're going to go ahead and get things kicked off. Good day, everyone. My name is Scott Anton. I manage sales strategy for Gideon Taylor, and I'd like to welcome you all to our GT Lunch and Learn for this month, how to apply PeopleSoft PUM images and CPUs with minimal downtime, more confidence, and greater peace of mind. Our speaker today is John Marcus, our Senior System Administrator. He's absolutely fantastic. He delivered this same session at the Blueprint 4D conference last month. And I think that it was standing room only. So I'm excited that he gets a chance to deliver it online today as our monthly webinar. For those of you who have not joined us for a Lunch and Learn before, this might be new to you. We host these Lunch and Learns on a monthly basis. Oftentimes, they will feature a solution or a service that is part of our forte. Here at Gideon Taylor, they might deal with GTE forms or our IDA digital assistant or our web UX solutions for user experience. Today, we're going to be focused on essentially PeopleSoft maintenance, something that you can put into practice as soon as you get off this webinar. So we're excited to share our knowledge with you. John Marcus has been doing this for a long time. As a company, we've been doing PeopleSoft support and implementation services for over 25 years. A little bit of housekeeping before I hand this over to John. We are recording today, so you will receive a link to the recording here in the next few days. And feel free to share that with others. You can also find the recordings of past Lunch and Learns both on our YouTube channel as well as our website. If you have questions, please feel free to post those in either the chat or the Q&A. We'll be monitoring those as we go along. If John takes a breath during his session, we can go ahead and raise questions at that time. Otherwise, we may choose to respond to those toward the end of the call. All right. I guess one more thing, for those of you who aren't familiar with Gideon Taylor, we are a full-service Oracle and PeopleSoft services provider, providing end-to-end services for PeopleSoft and Oracle clients, from implementations to upgrades to ongoing maintenance and hosting. We also provide a number of services and solutions to extend your PeopleSoft and Oracle applications, including our GTE forms and GTE flow products for workflow automation that can plug into not only PeopleSoft, but any application that you can think of to provide an enterprise-wide rapid application development tool that is driven primarily through configuration. And then we also have our IDA digital assistant, which is a conversational AI-driven chatbot that can plug into also any application that you might want or data source that you might want and have a conversational chatbot that is AI-driven that can help to support users wherever they are and whenever they might need help. And then finally, our web UX solutions, which allow you to completely reimagine your PeopleSoft experience, whether that is a student portal or HR self-service or a supplier portal or recruiting portal. It's a great solution to kind of reshape what PeopleSoft looks like to whoever your users are. That being said, I'm going to go ahead and hand this over to John Marcus. John, it's all yours. Take it away.
Awesome. Thanks, Scott. As for questions, I do have a dedicated Q&A slide, but if people post anything you think we need to address at the moment, feel free to interrupt me. You know as well as I do, I like to talk. So, all right. As Scott said, we are Gideon Taylor. We're in the PeopleSoft business, and we are all about efficiency in everything we do. And as he said, this session is about the most efficient way to maintain your PeopleSoft install and get all the benefits from that. I am John Marcus, the principal system engineer and OCI/cloud architect. Most of the architectural stuff we go over in this is my fault. Depending on who you ask, it's either my idea or my fault, depending on what day it is. So the first thing we need to talk about when we talk about PeopleSoft maintenance is what does maintenance mean for your environment in its current life cycle? Because the answer to that question and the definition of what maintenance means for your environment matters to how you go about maintaining it. Are you a fresh deployment that doesn't have any customizations? You want bleeding edge everything? Are you a retired environment that is only there for regulatory retention and thus you only need security patches to maintain security of the system? Are you a near end of life system that still needs regulatory and security patches, but you're not doing anything new feature wise, so you don't need PUMs, you don't need feature updates? Are you a mature environment that needs the full scrum? Tools, PUMs, security, regulatory, because you're still hitting it hard, you're still expanding people tools, you're still using new features in the various pillars. Um, so the definition there really determines what maintenance means for your environment, and you have to understand that before you even start to plan for it. Uh, and conversely, it's not a set and forget type thing. If you're just starting out, every time your environment enters a new stage of the life cycle, you need to reevaluate what maintenance means and how you achieve that, and what architectural changes you need to make to your system to allow you to achieve that. Uh, it's obviously easiest to it's obviously easiest to come up with a maintenance program if you're there from the beginning when the environment is first built. But luckily, you know, most of us weren't there for that, and luckily we are able to bring the system up to modern standards as we work on it to make it easier to maintain. The problem is you have pushback from the business, obviously, because you're making architectural changes to their system. Depending on how integrated you are with the infrastructure people, they may push back because you're requesting infrastructure from them. Uh, but really, it's your environment. You need to do what's best for it when it comes to how you maintain stuff. And something that's often overlooked when it comes to maintenance is your other layers in the system. I mean, you've got your database, the OS. If you have some kind of custom integration gateway software that runs, on a separate system to handle, say, protocol translation or anything like that, or handling features that the PeopleSoft integration broker doesn't handle natively, you also have to make sure they get maintained as well, because when it comes to especially security updates, and as we've seen in the last couple of weeks, security is a huge problem at the moment with PeopleSoft. Um, any unsecured system is potentially a pathway into your PeopleSoft. Once you define the problem, then you have to actually prepare the environment to be handled by your maintenance. As we all know, the percentage of legacy deployments far outweighs new deployments. Well, as I said before, you can bring an existing deployment up to modern standards. And the single best way to ensure your maintenance goals are achievable is to architect your system with maintenance in mind. Because especially if you're coming in on a system that was installed long ago, it's probably installed with the current best practices, and best practices change as environments change, as exploits change, and it's just not always, the best practice from 20 years ago, which some of these people systems are that old, is very different than the best practices today. And I cannot stress this enough. The architectural foundation of your system matters more than nearly anything else, especially when it comes to maintenance. Because a bad environment architecture will make it just miserable to maintain, and humans are disincentivized to do miserable things. So if your architecture is bad, it's not going to get maintained as well as it should. Ways to do this, there's several. I'm going to stress some of the ones we use the most. Standardize your deployments on modern patterns. There's several modern patterns that I've come across systems, even from 6-7 years ago, that don't leverage. Decoupled homes is a big one. I'm still occasionally finding PeopleSoft systems that have coupled homes. Coupled homes are atrocious when it comes to maintenance because you're touching essentially the entire deployment to change a couple of things, depending on whether you're doing like a regulatory update for tax updates or a security update. You're having to touch the entire, people tools and application software files, which is just a recipe for disaster in any modern scenario. You want to optimize your, well, actually, let me go back a step here. Along with decoupled homes, there's disposable environments. you really should be treating your environments. I'm going to use this phrase later. You really should be treating your environments more like cattle instead of pets. If one of them's acting up, just send it on down to the farm and reclaim its CPU for parts. And in a properly architected environment, that is easy enough to do, and it eliminates a lot of time spent trying to fix an environment that really shouldn't be fixed. And the last modern pattern I'm going to touch on for the moment is workload containerization. We're going to talk about it in a little bit, but I cannot stress enough how amazing containerization is when it comes to maintaining PeopleSoft. And we're going to have some statistics on that in a little bit here, based on last week's CVE that we all know and love. You got to optimize your architecture for continuous maintenance. Template your servers. Basically use a standard image for all of your systems. Stick to it. Don't do one-off changes to your image and a system in the middle of your life cycle. Like, if you have a dev, test, and prod, don't make changes to test and let it sit there. Force everybody to do it the right way when you can. You make the change in dev, test it, and then promote it up through, and make sure that all of that stays standardized. Because otherwise, it's just a landmine waiting for you when you go to do something later on down the line. Treat your environments like cattle, not pets. If thinking about killing an environment and rebuilding it and recreating it scares you, that's a sign that your architecture is not optimized for any kind of maintenance or, realistically speaking, any kind of disaster recovery. And that's, we're going to get into that a little bit here too, where disaster recovery should be intertwined with maintenance as well. Because A, disaster recovery is just unavoidable in today's world. And B, every once in a while you get a maintenance that goes wrong and you have to implement your disaster recovery plan. So the best way to be good at doing disaster recovery is to practice it. This goes back to, standardize your environment, make every deployment identical. You can change up, resource sizing, but prod should be a clone mirror copy of dev, which should be a mirror copy of QA. Every environment should have the identical software, identical config, other than environment specific config. You really want your environments to be interchangeable other than configuration, because that means A, your code's all going to behave the same. B, if something breaks in, prod, it should have broken in dev, and you should be able to test it and figure out why. And it makes when something goes wrong, having standardized environments is the number one way to easily fix it. Put it that way. And also, this is where containerized workloads come into play. Containerized workloads allow you to abstract your environment configuration away from the environment installation. So you can install all of the software, libraries, files, and then the container engine, we use Kubernetes. The container engine will actually apply your environment configuration to that image. And so that image executes the same no matter where you run it. You can set it up as a dev image. You can run it as prod. You can run it on your developer laptop, and it will always execute the exact same way. And Kubernetes also forces you into the cattle, not pets paradigm, because if a pod's misbehaving, you just kill it and fire up another one. And if it's a problem with something, bad state, that'll fix it. If it's a problem with your deployment, it'll be very obvious what's going on with your deployment when it doesn't come up. And last thing, really, with architecting your environment, you have to take, as an admin, an active role in managing your customizations and modifications to your environment. You got to make the business justify their customizations. Use modern patterns when they do have to customize. I mean, PeopleSoft delivers a ton of low code or low impact ways to customize delivered stuff. You got drop zones, event mapping, on the admin side, we have the PS Custom for SQRs and COBOLs. Take advantage of the tools that Oracle does give us, few though they may be in some cases, and make your life easier. Because if you don't, modifications are the bane of active maintenance. That'll be where you end up with your most errors. That'll be where you end up with your most issues, and that'll end up what causes you to have to roll back maintenance, is the customizations not being either remediated properly if they've changed in the new version, or not working, or any variation thereof. The next thing you have to understand with PeopleSoft is, it's I like to call it the onion architecture. It's a very layered object, and you have to be competent at every layer of that object to be able to maintain it correctly. You have to be able to, or your team, we're going to get into this in a little bit too, you or your team have to be competent all the way up from the networking layer to the web tier, and even all the way out to the systems that integrate with PeopleSoft, if they're ones you manage. Because that all has to be maintained as part of the PeopleSoft instance. And everybody knows when something goes wrong, it's not, oh, the database is down, it's, oh, PeopleSoft's down. Bad architecture is the leading cause of maintenance not getting done in a system, in my opinion anyway. That makes PeopleSoft maintenance, bad architecture makes PeopleSoft maintenance messy, dangerous, and in some extent, inefficient, and just painful for everybody involved. To really optimize your maintenance effort, you have to optimize your architecture. And the upside to that, though, is a well-designed architecture makes maintenance easy, repeatable, and importantly, recoverable when something goes wrong. But above all, it makes it tenable to keep maintenance happening on a consistent schedule. Maintainability is not a side effect of a good architecture. Maintainability is a core feature, among many other features that come with a good architecture. I'm going to quote Robert Heinlein for this next bit. He has one of my favorite quotes ever, and it's kind of, in a lot of ways, I read this book as a kid, and in a lot of ways, it shaped a lot of how I view competency in whatever topic you're talking about. But Robert Heinlein said, a human being should be able to change a diaper, plan an invasion, butcher a hog, con a ship, design a building, write a sonnet, balance accounts, build a wall, set a bone, comfort the dying, take orders, give orders, cooperate, act alone, solve equations, analyze a problem, pitch manure, program a computer, cook a tasty meal, fight efficiently, and die gallantly. Specialization is for insects. Now, there's some debate in the world about specialization being good or bad, but in the book, Heinlein's competent man ideology champions self-sufficiency in life. The modern tech landscape demands a similar set of skills for system maintenance. True maintainability isn't simply about updating a component or being able to modify a config file. True maintainability requires a deep understanding across the entire stack. And knowing how things interact, how changes in one layer affect changes in a layer further up or further down. It leaves you, a couple of options in how you cultivate this talent. You can either find highly competent individual maintainers. Aside from these people being fairly rare, they also introduce bottlenecks into the process. No matter how skilled a person is, there's only so much maintenance they can juggle at once. And if they're doing every layer, they're going to have burnout way sooner than another, more generalized or a more specialized maintainer. The other way you get it is highly skilled cross-functional maintenance teams. And this is where, like at Gideon Taylor here, my team has, we have a PS admin, a DBA, system admin, and they all work together at their various layers. And there's some overlap. So everybody has, everybody can cover everybody else to a certain extent, but everybody has their core competency that they're really good at. And we, assign tasks based on that, and nobody gets overloaded. The maintenance flow happens really efficiently, and you get really good work because everybody is specialized in their in their little thing, their little niche. But overall, the team functions like essentially like three highly competent individual people because of how we share tasks back and forth. And if your company can't find either of these, there's a third option. Shameless plug for Gideon Taylor here. You can outsource your services to vendors that can provide the expertise without the overhead. That's why I have a job, and we're really good at it. But that is an option, and it really ends up being, I think, more economical than most people think, and also allows, I always say, we have a customer that totally can do their own maintenance, but they hire us to do it almost every year because we can do it very efficiently and free up their admins to still handle the day-to-day stuff. Whereas if their admins were handling the day-to-day and the maintenance, they'd probably be overloaded to a certain extent. So outsourced services really can be efficient there. Now we're going to get into, once you've got your plan and how you're going to do it, we're going to get into execution a little bit. I'm going to give a little personal anecdote here. Several of my hobbies outside of work involve action at high velocity, whether that be, car racing, motorcycles, what have you. And, every one of those hobbies has a rule that generally boils down to never move faster than your ability to process what your senses are telling you. In a very subtle way, this is also true with PeopleSoft, but in testing. You never outrun your ability to test changes before you put them in. And that ties directly into the question of, how often should you do maintenance and how long should it take you? In an ideal world, the answer to the first question would be every PUM, CPU, patch, tax updates. But if you go with that answer, the answer to the second question is going to be impossible to sell to the business because you'd never be able to actually do any real work. You'd just be constantly maintaining your instance. So then you have to assign weights to various patch types. In the modern world, security and regulatory patches just are not optional. You cannot defer them. Not if you enjoy not being the target of litigation and courtroom drama. the recent CVE from last week, it shows just how quickly that can go sideways if something happens. And an anecdote with that, we patched upwards of, I want to say it was 70 environments in one day with 3 people last week because of the architectural changes I'm talking about here. Whenever we bring a new customer on that we host or help manage, we nudge them. We either re-architect and we bring them to the cloud, or we nudge them towards optimizing the architecture a little bit with every maintenance we do, so that we eventually get to a state where they are on par with our standard architecture designs and become just easy to manage that way. Once you have once you have security and regulatory patches taken care of, then you can start talking about new functionality and features. This is where, depending on the life cycle of your environment, you may not need this, or you may need to go to selective adoption. I'm personally not a huge fan of selective adoption because of the overhead it involves in building change packages and applying them and making sure that the code on the system, on the server itself is matching what's in the database. But it is a valid option if you're at that point in your life cycle. You also have to create a maintenance tempo that works for you and your business, because if your business can't test fast enough, we're back to you can't maintain fast enough. The business testing is essentially the hand on the throttle of your maintenance plan, because you can't go to prod without testing, and they have to be the ones to test. The biggest problem I see in the PeopleSoft world with maintenance is basically, a new environment gets stood up, and everybody's like, "Oh, let's do everything." And so you jump in, you do, your PUMs, your CPUs, your security patches, your regulatory patches, and basically you jump in at that level, and I can almost guarantee that you'll have maintenance fatigue in about 2 cycles, and eventually within a year and a half, you're probably not going to be doing updates of any kind because the business is just not going to want to do testing for you. And maintenance fatigue causes huge problems. Essentially, you get basically your users get tired of testing your maintenance, or you get tired of having to do maintenance, every, especially with PeopleSoft going now to monthly security patches. So you don't do it, or it gets sporadic, or even worse, it doesn't get tested before it gets moved in, and that is just a recipe for disaster, as we all know. Realistically, you have to create a maintenance plan that works for you, the business, and the end users, and stick to it. That is the hard part. It's really easy to go, oh, well, we don't want to do the PUM this quarter. We'll just do regulatory updates and do the PUM next quarter. But every time you do that, it causes an increase in the testing to then do the PUM. Or same thing with tools upgrades. If you defer your tools upgrades, every time you defer it, you're adding essentially testing debt to the next maintenance cycle. And you get 2-3 quarters of that, and pretty soon it becomes insurmountable without a huge 2 or 3 month project to be able to update your system. I have seen customers that are so far into that cycle that it takes projects so long to get say a tools update put in, that by the time they do, they're already out of date on that tools and are going to have to start again essentially to get caught up, just because of how long it took them to test and approve the maintenance that was done to bring them up to date. And again, the last thing on this slide, the best way to get good at something is to just do it a lot. You get good at applying PeopleSoft maintenance the same way musicians get to Carnegie Hall, with practice. Now, I'm going to caveat this. This is the same plan I presented at Blueprint, and it has not been updated to reflect the changes in PUM release schedule and security patching schedule that Oracle announced at Blueprint. But we're going to take just an example, PeopleSoft stack. You have an HCM, a financials, a campus, and an interaction hub. What would we as GT recommend for a maintenance plan for that, assuming you are in the actively using it, actively developing it stage of your life cycle? We basically break it down to, in this case, a maintenance every quarter. Your first quarter, you do your tools on Interaction Hub and regulatory and security patches for CS, financials, and HCM. And since it's a short patch quarter, you do your OS upgrades and database upgrades while you're in there, because you're already have a light maintenance anyway, since you're just doing regulatory and security, no PUMs, and only a tools and Interaction Hub. Second quarter, you do a CS, tools, and PUM, financials, HR, and Interaction Hub, regulatory and security, and then, if allowable, a deep database and OS patching. And we basically just cycle through where every quarter, one of the pillars gets a tools and PUM, and the other ones get regulatory and security, plus your ancillary patching. And by the time you get to the fourth quarter, every environment has had a tools and PUM that year, and are all caught up on regulatory and security updates. And if you do that, really it's 4 maintenances a year, every quarter. You're going to still be pretty busy. I mean, this is especially with I'm assuming you got active mods and stuff in HCM and financials and CS. You're going to stay busy, but you'll stay updated as well. And along with this, being updated helps kind of decrease the day-to-day PeopleSoft admin burden, because you're running modern code, modern stuff, and you're in support. If something goes wrong and it's obviously a Oracle problem, you can open an SR. Whereas if you're on an outdated version, the first thing I'm going to do is tell you to upgrade. The other thing you have to get comfortable with PeopleSoft maintenance is embracing calculated risk. Now, this is where you get into, how much can you reliably test? Because there is the urge, if you're doing one patching, if you're patching, a database, you may as well patch PeopleTools while you're in there. And hey, if you're patching PeopleTools, you may as well patch the OS. But you really have to be careful with that urge, because it can bite you if you're not careful with that. That leads to sometimes analysis paralysis, where you don't know when to stop adding stuff to the patch, and so your patch window bloats out to where it's untenable. Or in worst case scenario, you can patch too much stuff and introduce bugs that weren't able to be tested, and then it becomes an actual business problem, because the business now has an environment that's patched but isn't usable. And when you think about downtime, this is what I mean by calculated risk. When you think about downtime, you shouldn't think of it as you shouldn't think of downtime risk in terms of like maintenance risk in terms of downtime. You should think of maintenance risk in terms of danger to the user experience. Because if you tell the business that your system's going to be down for 12 hours to do a patch, they're going to grumble about it. But everybody knows every once in a while you got to have long patch windows. But if you tell them it's going to be down for 6 hours, and you put stuff in that wasn't tested, and then their user experience gets bad, that's when the users will really start complaining. And that's when you're kind of under the gun to fix it, because you broke it essentially. There are a lot of emerging options for simplifying maintenance. I'm going to get on my soapbox here and talk about automation and containerization, because they are my two biggest force multipliers for this. If it weren't for automation, we wouldn't have been able to patch 70 plus instances with 3 people in one day last week. And even that was fairly rudimentary automation, because it wasn't the automation we were using wasn't well vetted. So we logged in and actually ran the automation manually on each environment to make sure it ran okay. If we'd have had enough time to actually vet the automation, we probably could have done those 70 environments in an hour, just because of the nature of automation. Now, you are going to find containerization and automation require a big paradigm shift in how you think about your system. Containerization, especially, containerization came about from the developer world before it got into the system admin world, and so you kind of have to almost think like a developer to really get containerization to the point where you can be comfortable with it. But it is really worth it, though, in the end. But one thing to keep in mind is you can't think of containerization and automation as silver bullets or a cure-all. They function more like a magnifying glass, is how I put it. They will absolutely magnify inefficiencies or architectural issues you already have if you don't fix them before you start using the containerization and automation. You have to be good at doing things manually before you use automation, and your architecture has to be good when you containerize, or else it just makes it 100 times worse. My analogy here is that if you're not good at doing things manually, or good at have a good architecture, applying a containerization or automation is a lot like getting a 16-year-old a Corvette as a gift for barely graduating driving school. It will absolutely wreck, and people are going to get hurt, metaphorically speaking. But the good side to that is, though, once you successfully adopt containerization, it forces you to fix your deployments. You have to standardize your image, you have to standardize your software version, you have to standardize your processes for handling, migrations and maintenance applications. It forces you to hash all that out at the lower level, so that once you get ready to go to prod, it's already been tested at least twice, in dev and then a test environment. It makes it really very, very almost uninteresting going to prod, because it's just, you go in, apply some manifests, or push a button, depending on how your automation is set up, and it just works. And, it's kind of a crazy feeling watching it happen, because you realize, how long you've been doing it the other way, and Suddenly, you don't have to do it that way anymore. um, and it's one of those we've I've been playing around with doing tools upgrades, actually automating them with Kubernetes and our Ansible install, and it is actually really cool the first time you see a tools upgrade happen in an automated fashion in about 30 minutes with an automation running it. It's one of those, you realize just how much the game has changed when you see that happen and see it work, and then realize it's repeatable. But that's the best part. It's, you can say, okay, I did it here. Now I can go apply it here and here and here and everywhere else that has these standard environments because they're all following the same standardization. And of course, the last thing here is don't be afraid to ask for help. Maintenance and architectural design is a very different animal than day-to-day support. And I've generally found, very generally, that PeopleSoft admins generally fall into either great day-to-day admins or great maintenance and architecture admins. I've been told I fall into the latter. I just am not great at day-to-day admin, but I love the maintenance and architecture side of PeopleSoft administration. And the great part here is, if your team and business can achieve all the maintenance goals inside your windows, that's great. There's no reason to look outside for help. And if you can't, it's generally pretty cost effective. I mean, I'm not even saying GT. Basically, it's you're getting fractional PS admin, so it's generally very cost effective to just contract it out and have somebody else help you with it. And we're back to the one customer that can totally do it themselves, but hire us because we do it fast and we've got it down to a system, and it frees up their admins to do the day-to-day stuff. And at some point, you're going to come to a point, whether you're working on, basically, you come into a new environment and you're working on it, or you're working on a legacy environment that you maintain. At some point, you're probably going to find yourself struggling to maintain the environment because of architectural choices made, long before you came along. And I'll be the first to admit my tolerance for that has gotten very low. With all the modern architectural patterns that are out there, there is no reason to struggle with bad architecture. You know, Basically, if you find yourself dreading every maintenance because of the architecture, it's time to call a meeting and re-architect it to make your life easier. And you'll find once people realize that doing that also makes their life easier, like for testing and patching and that kind of stuff, the business gets on board really quickly with it too. Once you get there.
John,
Yes.
if I can interject for a moment, there's a question in the queue that I thought before we get past that slide that you were just on, you had
Okay.
mentioned that you use some tools to automate maintenance tasks.
Yes.
And this person is asking, what tools are you using for automation?
That's a great question. So we actually, our automation platform is built on essentially Ansible, as packaged in the Oracle Linux Automation Manager, which is a open source, essentially Ansible Tower GUI for the web. And we use that in conjunction with Kubernetes, like Kubernetes jobs and Kubernetes tools images that we've built. There is a fairly steep learning curve to get those up and running, and even steeper to get them usable and where people will use them, to think about using them first. Totally worth it though in the end. Like I said, I think if I had had a little more time to test our automation that we wrote for that CVE last week, to where I was comfortable just pushing a button and having it run against all 70 environments, we probably could have done that in an hour instead of 8. So automation is definitely the way to go, and I can't recommend Oracle Linux Automation Manager enough. It is amazing. It happens to be open source and free, so there's that too. All right, and now the solid plug for automation and containerization. That's a mouthful. I have to change that wording up the next time I do this. First question is, what are they? Automation obviously is the easy one. Using an automation platform to execute jobs against your instances to eliminate manual tasks. Containerization is a little bit more abstract of a concept. Containerization, or more properly, workload containerization, is a modern approach to app deployment that packages software with all its. And I apologize, I am actually reading this verbatim because it is fairly in-depth. It's a modern approach to application deployment that packages software with all its dependencies, libraries, frameworks, and configurations into a standardized unit called a container. This self-contained environment ensures consistent application behavior across different computing infrastructures, from developer laptops to cloud environments. Containerization isolates applications, improving resource utilization, portability, and scalability. By abstracting away the underlying infrastructure, containers simplify development workflows, accelerate deployment cycles, and enable efficient management of complex distributed applications. Of course, there's several popular ones, Docker and Kubernetes. And even they have their own little sub niches that further automate the orchestration and scaling of their workloads. How do you leverage it? Automation is the easy one. You can leverage automation with your existing architecture. Doesn't matter what state it's in. It can be automated. We started out with the low-hanging fruit. Domain restarts, minor config changes, database administration. I mean, I have automations for a couple of the other teams at GT that allows them to do their own domain restarts and add and remove database users for their internal development environments without any intervention from us. They just go in, put in the info that's required, hit submit, and depending on what it is, sometimes we have it ask us for an approval if it's something that's somewhat dangerous or security related. Most times it just goes and does it itself. We don't even ever see that they had to do it. Containerization, that's a trickier one to leverage. You kind of have to go all in on it. By the time you set up, and we have an advantage. We use the Kubernetes engine from Oracle in the cloud, so we don't have to maintain our own control plane and nodes and all that. But you do have to buy in big on it, and there is a time investment to get up and going on it. It's not nearly as quick to set up as automation is. Something else I was going to say about that, but I can't remember what it was. Oh, yes. The other really cool thing about containerization is, since you work off images, there isn't necessarily an OS that you have to manage. As long as you're building new images for tools updates, you get all of the OS updates as well. So there's no separate OS patching involved in that. And in fact, one of the really points of containerization is it removes everything extraneous from the base OS image. So you don't get like a lot of the images we start with as our base. You don't get wget or curl or DNS utils or anything like that. So the attack surface is very, very thin when it comes to containers, and that's compounded by the way that the networking happens, which is well beyond the scope of this. But containerization ends up being by design, a lot more secure if done properly than a standard VM running your instance. And what tools do I recommend? As I said, I use Ansible in the form of OLAM. We call it OLAM, and Kubernetes. We use Git for our repositories, and there's a few homebrewed scripts I've written to do things here and there. But by and large, Ansible and Kubernetes are the two big ones we use. The next problem you're going to have is what happens when something goes wrong, because something will go wrong at some point. It's just the nature of touching complex systems that something is going to break. It's just inevitable. So what do you do if something goes wrong? There's a nice acronym. The last part of it doesn't apply to this, but it's an acronym I learned in one of my hobbies: stop, look, listen, smell. You don't want to smell if you're in the server room necessarily, but if you're doing something and something's not working right or something's not coming up, stop for a minute, look around, listen to your logs. There's a very human urge to do something when something goes wrong, even if you don't know what to do. You don't want to fall prey to that because a lot of times that initial something you do will probably make it worse. Instead, when something breaks, take a minute, gather your wits, look at the situation, and then get to work. every problem is solvable at some level as long as you've done your part in preparing for something to go wrong. And in that regard, you do have backups, right? If it ends up being broken so bad that you don't think you can fix it in a timely fashion or inside your maintenance window, that's what backups are for. Wave off, roll back, and try it another day after you figure out what went wrong. When my team does any kind of significant maintenance on a system, we always have at least 3, sometimes 4 plans, depending on the customer and depending on the environment. There's the primary plan, what we'd like to see happen if everything goes right. There's the alternate, things that could go wrong, we account for in the alternate and how we handle them. There's the contingent plan, which is if the primary and alternate both fail, what do we do? Do we keep going? Do we roll back? And then there's the last one that really only applies if you're doing high risk maintenance, the emergency plan. What happens if the database gets corrupted? What happens if somebody drops a table? There's all kinds of things that can go wrong that necessitate doing disaster recovery, essentially. So you really want to have your, the acronym for that is PACE: primary, alternate, contingent, and emergent. You really want to have your plans laid out in advance, so you're not trying to figure out what to do in the moment when something does go wrong. And you always have to have a good rollback mechanism. Mitigates risk. Basically, even if your maintenance fails, a good rollback plan can ensure you have a successful maintenance because the system comes out intact on the other side. As long as the system comes out intact, yeah, it may not be at the state you want it to be in, but at least it's intact and workable, and you're not causing user experience issues. And the big thing here is be comfortable being uncomfortable. Every once in a while, you're going to get emergency maintenance. I touched a bit on the CVE that we all saw last week. Every once in a while, life or Oracle throws a curveball at you, and you just have to roll with it. And there's no way to ever be comfortable with that. I know it felt very weird for me logging into several customers' prod environments doing stuff last week in the middle of the day on a Thursday. But, you got to do what you got to do. And the last part is disaster recovery is inextricably intertwined with maintenance. You cannot have good maintenance planning without also having a disaster recovery plan. It's not optional. In most cases, and in some cases, depending on what your business is, it's a requirement. It's a regulatory requirement. And if it's not, it should be a good best practice. You always need to have a disaster recovery plan, and you need to exercise it occasionally. We have one customer that for 2 weeks of every year, they actually exercise their DR plan and move their entire system to a different region in the cloud just to make sure their DR plan works. And it's the only customer we have that I know of that does that, and I applaud them for that, because it's a gutsy move, but it also means that they know their DR plan works, which is more than can be said for a lot of people. And really, disaster comes in all forms. Sometimes it's a corrupt database. Sometimes it's a PS admin pushing the wrong button and change assistance. I mean, I'm not ashamed to admit, early on in my PeopleSoft admin career, I did that. I pushed the wrong button and completely broke a database to the point we could not get it back without a refresh from the backup. Sometimes it happens. Luckily, we had taken a backup. Luckily, it was it took longer than the maintenance window to get it back online, but we brought it back online, and there was no long lingering effects from it. But it happens. You just got to learn to account for it in your planning. And of course, you got to watch your blind spots. I can't tell you, I've seen several times where Oracle releases a PUM and then it'll go actually release a revision to that same PUM and not say it anywhere. And so you install the PUM, or you use an old ISO that you built from it, and it stops working. Also, I've seen them release it and then have immediately required PRPs that you have to install for some feature to work in the PUM when you're installing it. You got to watch the release notes. Release notes are the key to life in Oracle. Watch a certification list. I've had a couple of customers, and even internally, we've had a couple of times where we've inadvertently wandered off the certification list. And while it still worked, we were in a precarious position if something decided to break, because Oracle's going to, shake their finger at us and say, you're on your own. And just as a rule, pure Oracle, Oracle Linux, Oracle Database, Oracle PeopleSoft will always be easier to maintain and have better support than other supported systems. Windows, AIX, MS SQL. Oracle just really supports Oracle, and everything else is an afterthought, as those of you who use things besides Oracle know in some cases. And I put this in the unexpected gotchas. I don't know that it's right there, but post-maintenance validation is something that never gets much love. When you're doing something, you always have to verify that your maintenance worked. You go in, check the feature you moved, or go in and have the functional or the business go test it in production once it's in there, and make sure that what you did had the effect you thought it did. Because sometimes it doesn't, and sometimes you're scratching your chin wondering why, until you realize, oh, I forgot to move this, or this DMS failed, or various reasons. But this keeps you from leaving it in a bad state before you hand it back to the business for them to continue on with the business. So don't ever skimp on post-maintenance validation. And yeah, Q&A. Any questions?